Hearty welcome to the Fairytech channel. Now we are about to see the sweep circuit using transistor switch. In this video, let us go.
Design a sweep circuit which generates exponential signal or sweep signal using exponential circuit as shown in figure, and we have used UJT as a switch for generating the sweep signal in the last class. And now we will see how a sweep signal can be generated using transistor as a switch. So here the switch is used directly in like open switch. Here in the place of switch we have used a UJT transistor. Now we will see a circuit which generates a sweep signal by using transistor BJT transistor as a switch. Now how this actually works, see, in this circuit, before giving any input signal, this Vi, this transistor base is connected to the supply voltage through a resistor R dash. Means this transistor gets a sufficient drive from this supply source through R dash, and this transistor is actually in by default in on condition. So when this is in on condition, means the collector voltage what you get here will be a minimum voltage of VCE sat. VCE sat voltage will be appearing here. Now what about this input signal? This input signal is a pulse signal which can be a signal from the output of a monostable circuit. If this input signal is output of a monostable circuit, then this circuit can be called as a triggered sweep circuit, and this input may be the output from a stable circuit. So if this input signal is coming from an output of a stable circuit, then this circuit can also called as free running sweep circuit. So how this actually works, let me describe, let me explain this. See, before giving any input signal, means by default, so let us say in this timing waveform, so by this pulse Vi is coming from a gating, is the gating signal, and let us take this instant where it is going negative direction, that is at t equal to 0. So before giving, means before this negative trigger is given to the transistor, so by default the output is clamped to a minimum value called Vv. So this Vv is the minimum output voltage without applying any input signal Vi. So this Vv we can call that as a VC sat, the transistor's collector to emitter voltage, which is VC sat when this is in on condition. Now when this input signal is lowered, means when this went in a negative direction, then this negative signal is negative trigger is applied to the base of the transistor, which makes this BJT transistor completely off because of this negative input. So when this transistor gets turned off directly, then this doesn't have any relation or connection with this capacitor. Now this capacitor charges from the supply VYY through resistor R linearly as shown in figure. See, before applying this negative input, before at t equal to 0 or t less than 0, the output is a minimum value of Vv, and when this input signal negative trigger is applied, means after t equal to 0, the BJT transistor turns off and the capacitor starts charging. The capacitor starts charging to a maximum value, and when it reaches to a maximum value called peak voltage Vp, and then again this transistor turns on and the output voltage gets decreased exponentially. Means this, when this transistor turns on, this capacitor charge which is stored here gets discharged through this transistor in an exponential manner. This is how this transistor is used as a switch. Means here BJT transistor serves the purpose of switch in generating a sweep signal like UJT in the previous class and switch in the previous class. See, in question the same explanation is here given. See, for 0 less than at t equal to 0, the input goes to lower level and remains at that level to the time period ts. This is sweep time. So for 0 less than ts, the transistor remains cut off, the capacitor charges through R towards VYY with a time constant RC, and when it reaches to the peak value at the end of the sweep time Ts, here the input has gone back to its normal position, positive value. When positive value is given, again when this is positive, now this transistor gets a sufficient drive from supply source VYY through R dash, again this becomes on. When this is on, again the collector voltage or the output voltage is clamped to a minimum value of Vy, and it exponentially decreases.
If you like our videos on electronics and circuits, kindly visit the playlist of our channel called Feritech. You can go to the channel playlist and you can search those videos in the electronics playlist. And also you can browse through so many playlists which are very useful for your career, academic and research activities. And also you can suggest us what are the changes we are about to do in our channel so that we can be very helpful to every one of you. Thank you. For more videos other than electronics or any other topics, you can come to our channel Fairytale. You can like, share, and subscribe our channel. Hope you will get some suggestions from your side also.